Alright, so very quickly we already come to our chapter 3 for paper 3 maths. Alright, okay, so for chapter 3 we are going to talk about trigonometry identity, and for this chapter there are a lot of identities. I think all the identities you learned before, okay, just that now you need to know how to apply all this identity in A-level exam style questions. Okay, so maybe last time when you learn the identity, you know how to apply it, but maybe the application is quite simple and straightforward one. Alright, but for A-level style question, it can be quite complicated. So besides learning all this, you need to get used to the exam style question. That's why I said, okay, there are a lot of knowledge that you learned before, but when you come to the exam style, you might realize that the A-level exam style question will be usually slightly harder. Okay, so for today's video, we are going to discuss some very basic function first for trigo. Alright, so let us have a look at the learning outcome 3.1. They want you to understand the relationship of secant, cosecant, and also cotangent function. So all this you learned it before, right? Okay, and we didn't learn this in AS level, so we are going to learn it now. The secant, cosecant, and cotangent. What is the relationship between them with cosine, sine, and also tangent? And also they want you to use the properties and also the graph, okay, to find the value for angle of any magnitude. Alright, so again, you need to actually apply the concept that you learned in AS level before, so that you can use it to find the find the value of some certain trigo. Alright, okay, so we'll discuss this later. Right, so let's have a look for the very basic definition. Okay, so when they are talking about secant is SEC and then theta. So when you're having secant theta, it is actually 1 over cos. Cosecant theta is 1 over sine. Okay, so just take note that cosecant, I'm writing it as COSEC. Some other book they write as CSE. It is also cosecant, alright, CSC, so cosecant theta. Alright, then for cotangent, it is actually 1 over tangent. So you should know also 1 over tangent, you can also write it become cos over sine. This is something that you should know. Besides 1 over tangent, sometimes it will be easier if you want to solve the question related to cotangent, you change it become cos over sine, it will be slightly easier. Right, it depends on the question style also. Right, okay, so this is a very basic introduction for secant, cosecant, and cotangent. Alright, then now we talk about the sign. When will be the trigo function positive, when will it be negative, and so on. Right, so generally it will be the same as what you have for sine, cos, and tangent. So first quadrant, last time when we learned, right, everything is positive. Okay, then sine is positive in the second quadrant, tangent is positive in the third quadrant, and cos is positive in the fourth quadrant. So the similar related identity also have the same property for positive and negative in the quadrants. So as an example, cosecant is actually 1 over sine, right? So cosecant will be positive in the second quadrant. Cotangent is 1 over tangent, therefore it is positive in the third quadrant, and also secant is 1 over cos. So 1 over cos means that it is positive in the fourth quadrant. So this is the information that you need to know. It's very basic, right? They might not be asked you always, but this is some very small details that you should know. Okay, all right. Then now let's talk about positive angle and negative angle. So positive and negative angle, you learned it before. Right, so we are having positive angle and we are having negative angle. So positive angle means what? It is in anti-clockwise direction. That means when you measure the angle, you measure in this direction. Okay, and then when you are having negative angle, so negative angle, you actually measure it in clockwise direction. So which means when you want to measure the negative angle, you measure it in this direction. Alright, so we call it as clockwise direction. Okay, so this concept basically is still the same like last time, right? Like what we learned last time. Okay, then after that, in our notes, I attached the negative angle formula. So if you want, you can memorize, like sine negative x equals to negative sine x, which means cosecant negative x also equals to negative negative cosecant x. So for me myself, I didn't memorize all this one. I don't like. Okay, so I'm having my own way to find out the value. But for those who prefer to memorize, you can try to memorize it if you want for the negative angle part, right? Then for complementary angle, so complementary angle is also the same. When you're having sine theta equals to cos 90 minus theta, it will be equals to cosecant theta equals to secant 90 minus theta. Okay, so I can tell you that for our syllabus, these two are very important. We will use it quite often, but all other thing is not so important. So all these are for extra knowledge only, right? But these two are really important. Usually in the exam style question, you might need these to solve the question as well. All right, so I think you need to remember it. Okay. All right. Then now, let's come back to the negative angle and positive angle. So just now I tell you that I didn't memorize the formula, right? I don't like. But generally, what is the method that I use is the 4-quadrant graph that I showed you before. Okay, because I think I show you here, right? You're having all sine, then tangent, cos. Right, so when you are having the first quadrant here, we always call it as theta. Theta is the basic angle. So for the second quadrant is 180 minus theta. Third quadrant is 180 plus theta. And fourth quadrant is 360 minus theta. Okay, then for negative angle, usually what I do is like the first quadrant, the fourth quadrant is where we start with negative theta. And then negative 180 minus theta. Negative 180 plus theta, and then negative 360 minus theta. So I'm still using this quadrant, okay, this summary to find all the value that I want and to solve the question. All right, so to me, myself, this is the only angle, the only summary that I refer to. But of course, you need to know the basic graph for cos and sine. But this is a summary for me, usually used to answer the question. All right, or to find out the negative value for the triple. Okay, so again, this is not the only method. Of course, everyone will have your own method. If let's say maybe last time you learned some other method, it's quite easy one, you can apply also. All right, okay. But for discussion, usually I will use, I'm using this, all right, to discuss. So hopefully you roughly have the idea what am I talking about. Okay, so now, after the complementary angle, okay, so let us continue to draw a reciprocal function. Okay, so this is very important. To me, it's very important. And then, why do I need to know how to draw the reciprocal function? Because reciprocal means 1 over fx. So like, if let's say I want to draw or sketch cosecant theta, how can I sketch cosecant theta? It is 1 over sine, right? Therefore, you need to know the sine graph first. Then after that, you convert it into cosecant theta. All right, so that is what we call as reciprocal function. Okay, so that means if let's say you want to sketch cosecant theta, it is actually equals to 1 over sine. So your original function is sine. So you need to draw the sine first, sine graph first, so that you can convert it into cosecant theta. So this is what we call as reciprocal function. Okay, so to me, why is this method important? It is because of I don't like to memorize the sine, cosecant, tangent, and secant graph. All right, so why do we need to memorize? Because they will ask you in the exam. They will ask you to sketch secant theta. They will ask you to sketch maybe cotangent theta. All right, but to me, I lazy to memorize the original graph. I'm lazy to memorize all these 3 graphs. To me, I think sine, cos, tangent is good enough. Okay, but if let's say you really like memorizing one, then please memorize the extra 3 graphs here. Okay, cosecant, secant, and cotangent. You have to memorize it. They will ask you in the exam to sketch the graph. All right, so for me, because I'm very lazy, I don't like to memorize a graph. Therefore, I will use this concept, okay, to help me to sketch the graph. Okay, so to know this concept, what you need to do is like, first, you need to know some very basic idea. Like, okay, if I'm having an original function is fx, and then when I'm having a reciprocal function is 1 over fx. Okay, so if you are having maximum point in the original function, when you want to draw 1 over fx, it will become minimum point. So that means originally it is maximum point. When you take 1 over, it will become minimum point. The same thing happens if let's say finally you are having minimum point. Then when you want to sketch 1 over fx graph, then that minimum point will become the maximum point. Okay, then the third one, when I'm having 0, okay, in the original graph, and I can change it become infinity or asymptote in the 1 over fx graph. So the other way around, if let's say I'm having asymptote in the original graph, when I'm drawing 1 over x, it will become 0. Okay, so by memorizing these four concepts, it will help me actually to sketch the graph for secant, secant, and cotangent. Alright, so for me, I don't really memorize the graph itself. I only memorize the rules here. Okay, so now I'm going to show you how to apply this rule. Okay, I want to sketch secant theta, maybe for one cycle, alright? Okay, so before I sketch a cosecant theta, because I know that originally it is come from sine theta, right? And then you are taking 1 over sine theta. Therefore, I sketch the original graph first. I sketch a sine theta first. Okay, so maybe I'm using this. Okay, so sine theta for one cycle. So maybe sine theta for one cycle will look like this. Okay, and then if you want, you can try to label it. So this one is pi over 2. This one is pi. This one is 3 pi over 2. And this is 2 pi. Okay, and then this is theta. And this is your y. Alright, okay, so for the red color graph here, this red color graph is actually your sine theta, original graph. Okay, then now I want to draw cosecant theta. Okay, so to draw the cosecant theta, what I need to do is I need to apply this rule, all the rule here. Okay, so first of all, oh sorry, I forgot to label something here. I forgot to label this is value 1, this is value negative 1. Okay, alright, so now, first rule, original graph maximum, when you take reciprocal function, it will become minimum. Okay, so where's the maximum point in the original graph? So this is the maximum point in the original graph, right? So at this part, okay, the maximum point will be converted, become negative. Okay, so what is the negative? Oh, sorry, it will be converted, become minimum point. So maximum is 1, right, the value? Okay, then when you want to convert it into minimum, then it will be 1 divided by the 1 you put it here. So it is still 1. Okay, so another example, if let's say your maximum is 2, then what is your minimum point? So your minimum point will be 1 divided by 2. Okay, alright, so our case is this one. Okay, original value maximum is 1. Therefore, when having minimum, it is equals to 1 divided by 1, it is still a 1. So that means my minimum is here. Okay, so minimum, that means you will have a curve something like this. But I still don't know the overall curve yet. Okay, so I will just draw a small curve like this to remind me that, okay, this is actually a minimum point. Okay, right, is there other maximum point again here in the original graph? No more, right? Okay, then now let's proceed to the next rule. Okay, so what do we have in the next rule? So the next rule is the minimum point in the original graph will be converted, become a maximum point in the reciprocal function. Okay, so I need to find where is the minimum point first. Here. Okay, so originally the minimum point, the minimum value is equals to -1. So when I want to change it become maximum, in the reciprocal function, it will become 1 divided by -1. So it is still -1. So that means I will still draw a point at the -1 here, and then it is maximum point, right? Therefore, it will look something like this. Okay, but I don't know my overall graph yet. Okay, I just know that the shape will be something like this. Okay, so for the third case, is when your original graph is equals to 0, and when you want to draw the reciprocal function, it will become asymptote. Okay, so where is the 0 for your original graph? There are a few right here. This one, and also this one. There are 3 zeros here in the original graph. So when you want to draw the reciprocal function, all these three values here will become asymptote. Asymptote means that it will actually become a straight line that the graph will not touch it or will not go through it one. Okay, so at this point it will become the asymptote as well. Okay, and also this one it will become asymptote as well. Okay, then after that you go for the fourth rule. Originally, if you are having asymptote, then when you draw the reciprocal function, it will become 0. Okay, so if you look at asymptote, do you have any asymptote in the original graph? No, right? So there's nothing that you need to do for this rule here. Okay, so once you completed to go through all the rules already, then now you can roughly guess the graph. Okay, so you're having 3 asymptote here, and your graph there's a minimum point and there's a maximum point here, right? Okay, so when you want to extend the graph, so the curve usually it will keep on going up one. It will not like go up and suddenly go down. Suddenly go down, that means that got some other rules that they will tell you. If let's say the curve suddenly go down or whatsoever. Right, but for what we learn for now, our curve will usually move on smoothly. So that means if let's say your curve, you're having a minimum point like this, right? So the left hand side, actually the curve should go up smoothly. Okay, and then because I know that this particular line is a asymptote, therefore when I draw the graph and goes on smoothly, it will getting closer and closer to the y-axis, but it will not touch the y-axis. So similar thing happened on the right hand side. Okay, the curve will keeps on going up smoothly, and then it will getting closer and closer to the asymptote, but it will not touch it. So your graph will look something like this. It is something like a U shape. Okay, and then for this part also the same. The graph will go down smoothly, getting closer and closer to the asymptote also. Okay, and for the right hand side also the same. So from here you will see that your graph for cosecant theta is in green color. Okay, so the green color is cosecant theta graph, and then for the red color it is actually 1 over sine. So usually in exam, when I want to sketch cosecant theta, I will use this method. Okay, so maybe you will say, wow, draw a graph and I use such a long time. But actually after you draw a few times, right, you know the idea already, how to draw correctly. Okay, so this is how I usually, how I apply the rules here to sketch the cosecant graph. Okay, all right, so if let's say you are interested, you can try to use the rule here to draw also the secant graph and also the cotangent graph. All right, so actually I attached the answer here already for you. The original graph and also the reciprocal function. All right, so if let's say you're interested to figure out this method correctly, okay, then you can try on your own by referring. Okay, by refer you find answer and find the graph here. Right, so I'm not going to discuss all the 3 graphs for you here, so you can figure out yourself. Okay, if let's say you're really lazy, you don't like to figure out this new method here or all the rules here, you just memorize all the graph or Trigo. So you choose it yourself. All right, for me myself, I choose this one. Okay, I lazy to memorize all the graph lah, and then someone need to know what is the value for all the asymptote and so on. So I lazy. Therefore, I prefer this. Okay, so this is how we sketch a graph. So again, for the Trigo graph, it is very important because in exam style question, actually they will ask you about it. Okay, and most of the mostly they are asking you in chapter 6. The question usually combined with chapter 6 in A2 syllabus, right? Okay, so maybe we can have a look here also for example 1. Okay, so for example 1, it is a partial question as you can see. I only take out one part of the whole question. Okay, because the other part we cannot solve yet. It will involve the knowledge in chapters, right? Okay, so I just take out the very first part of the whole question. Okay, so here they say by sketching a suitable pair of graph, show that the equation, this equation, where x is in radians, has a root in the interval this one. Okay, so what the question one actually for this one? Very obvious, they want you to sketch graph. Sketch how many graph? A pair. That means there are two graphs that you need to sketch. Okay, so what kind of graph you need to sketch based on this equation? Okay, and after that they want you to show that this equation has only one root in this interval. Okay, so there are a few information which is very important here. But first you need to know you need to sketch two graphs. Okay, so what is the graph that you need to sketch? Okay, so first you need to sketch a graph from the equation here. The first one you need to sketch is y equals to cosecant x. Okay, then the second graph that you need to sketch is y equals to x plus 0. Alright, and then from where until where you need to sketch your graph. So the domain that you need to sketch your graph is from 0 until pi over 2. Okay, so maybe we focus on these three first. Alright, so from 0 until pi over 2 means 0 until 90 degree. You cannot write 90 degree. Okay, you can only write it in radian because for all the calculation for trigo includes sketching graph and then deviation, integration, all those things, right? Everything must be in terms of radian. Okay, especially they involve with linear equation or quadratic equation or polynomial or whatsoever. Okay, so everything must be in the unit of radian. Alright. So they want you to sketch the graph from 0 until pi over 2. So this is pi over 2. Okay, so if you still remember the graph that we draw just now, cosecant x or cosecant theta, the pi over 2 is actually a asymptote. Okay, so if let's say in the exam you don't know, either you memorize it or either you apply the rules just now that I show you. Okay, then after that when you sketch a graph, you know that at pi over 2, I shouldn't say that this is asymptote. It is not asymptote, it is a minimum point. Alright, so at pi over 2, you should have a minimum point at 1 for the cosecant graph. So that means the graph will look something like this. And then after that, you go up, right? Just that for this question, they only want us to discuss until pi over 2. Therefore, I will stop here for pi over 2. So this is the y equals to cosecant x. Okay, and then for y equals to half x plus 1, this is a linear graph. So what you need to do is that you let x equals to 0, you'll get your y equals to 1, right? So x equals to 0, y equals to 1 means here. And then you can let another value. You can let also maybe you can let x equals to pi over 2 and then you get the value for y if you want. If you don't want, then you just use common sense. This is a linear equation, right? With positive gradient. Therefore, your graph will go up like this. Okay? So the blue color graph will be y equals to half x plus 1. Okay, so in the exam, you don't need to show them how you sketch a graph. You can straight away sketch the graph out. No need to show them how you sketch. Alright, you just straight away sketch the answer for them. Okay, but of course you must label them and also label some important values. So like this one is pi over 2 and so on. Okay, then now after you sketch it already and label it clearly, okay, so now you have to answer the question, what they want you to show. They want you to show that there's one root. So when they talk about how many roots, that means how many intersection points when you draw the graph, okay? When you sketch the graph for the equation. So to show that there's only one root, you need to prove that there's only one intersection point here. So I think very obvious that this is one intersection point. Okay, so therefore in your solution, you should write, okay, there's one intersection point can be seen. And therefore, you have one root. Okay, in the interval 0, x until pi over 2. Okay, so this is how we sketch the graph and also how we answer the question that they want. Alright, so the green color part here must write out because they actually want you to write out what is the reason that you tell them there's only one root in the interval. So the reason is there's only one intersection point. So how we know that there's only one intersection point? We can get it from the graph. Okay, so again, when you sketch a graph, please make sure that you label them correctly and also put in some important values if possible. And after that, don't forget about the reason and also the operation. Okay, so this is how we actually answer the question and how you sketch the graph. Alright, so for here I already the part that, okay, you draw it slowly. So in exam, actually you need to imagine a bit how you start to sketch cosecant x from sine x. Okay, so hopefully there's no problem. If no problem, we proceed further to another example, example 2. Okay, so again, by sketching a suitable pair of graphs, they want to show that this equation, okay, has only one root in the interval 0 until x until pi over 2. Okay, so you should pause. Maybe you should pause the video here and you attempt this example because it is very similar to the previous one, right? Okay, so I think you should pause it and you first before you look at my answer. So for this example, I'm not going to discuss how we do it. I will just straight away show you the final answer. Okay, so you better pause it now and try. Okay, so if you didn't draw it wrongly, right, you should have something like this. Okay, so this is y equals to tangent x. And after that, I'm having value 1 here. And then the graph is the curve going up. Okay, so this is y equals to 1 plus x squared. So your answer should look something like this. And then you should tell them that, okay, there's one intersection point can be seen. And therefore, there's one root in the interval. Alright, okay, so this is how we do it. So again, how to sketch the correct graph for cotangent x depends on whether you want to follow the rules that I showed you just now or you purely memorize it. Up to you. Okay, so don't forget about this. A lot of students, right, in exam, they always forget to do revision on how to sketch a graph and eventually they cannot get the marks for this one. So usually if you didn't draw it correctly, you will lose maybe 1 or 2 marks. Not many, okay, not many, but it will be good if let's say you can memorize all this. Alright, okay, so this is where we apply the sketching of graph for cosecant, secant, and also cotangent. Okay, right, so we'll stop here for this video. Then next video, we are going to discuss another 3 examples, not on sketching graph, but how to solve some very basic trigo function. Like how to find some very basic trigo functions such as what's the value for secant 270, what's the value for cotangent 330, and so on. Okay, so we'll stop here and then we'll discuss the other 3 examples in the next video.